Have you ever come across a SAT exam geometry question that looks super simple but actually hides a big twist? Well, here's one that fooled a lot of students. We are given a right-angled triangle with its base of 15 units and a height of 12 units. Inside this right triangle, a semicircle is formed in such a way that its center lies exactly on the hypotenuse. And our goal is to find the area of that semicircle. You can pause and take your time to solve this problem, and when you're ready, you can always come back to check your answer. All right, let us solve it together. Let's first mark the center of this semicircle. We are having the center of this semicircle lies on the hypotenuse of the right-angled triangle. So let's mark this point right here on the hypotenuse as the center of the semicircle. Now we need to draw two radius from this center point to the other two sides of the triangle, like this. These two sides of the triangle touch the semicircle externally. That means they are tangents to this semicircle. So as per tangent radius theorem, that is, when a radius is drawn from the center to a point where the circle touches a tangent, it is perpendicular to that tangent. This angle here is 90 degrees, and this one is also 90 degrees, right? Now look carefully at this shape formed by the two radius and the two tangents. These two angles are 90 degrees, and we are given that this angle is 90 degrees. So this fourth angle must also be equal to 90 degrees, right? So after observing, we can know that the figure is square. Hence, all the sides are equal. So this length must be r, and this length over here is also r. Now let us see the base of the triangle. The total length of this base is given as 15 units. So if this length is equal to r, then this remaining part must be 15 minus r units. Also, the total length of the height is given as 12 units. And if this length here is r, then this remaining part must be 12 minus r units, correct?
Now, as we can see this triangle, it has a base of 15 minus r and a height of r. So the area of this triangle will be calculated as r times 15 minus r divided by 2. Similarly, this other triangle has a base of 12 minus r and a height of r. So the area of that triangle will be r times 12 minus r divided by 2. And the area of this square will be r times r. So let's multiply and divide this r squared by 2 and rewrite it like this.
Have you seen something? This right-angled triangle is divided into three parts. First triangle at the top, the square in the middle, and this other triangle at the bottom. So the area of this entire right-angled triangle is the sum of these three parts, correct? We are given the base of this right-angled triangle as 15 units and the height as 12 units. So the area of the triangle is 15 times 12 divided by 2 equals 90 square units. Now solving the equation for the area of these three parts, we get r times 15 minus r divided by 2 plus r times 12 minus r divided by 2 plus r times 2r divided by 2 equals 15 times 12 divided by 2. Now taking r common from this side, and we cancel 2 from the denominators, that is multiplying both sides by 2. We get r times 15 minus r plus 12 minus r plus 2r equals 180. Solving the bracket first, 15 minus r plus 12 minus r plus 2r equals 27. So this becomes 27r equals 180. Dividing both sides by 27, we get r equals 180 divided by 27,
which is equals 20 by 3 units.
So the radius of this semicircle is 20 by 3 units. The area of a semicircle is calculated by the formula pi r squared divided by 2. So putting the value of r, we get area of the semicircle equals pi times 23rd squared divided by 2 equals pi times 400 over 9 squared divided by 2 equals 200 pi divided by 9 square units. That is our final answer. Pretty cool, right? What looked really tricky at first turned out to be much easier than expected. But before you go, here's a bonus challenge for you. Can you find the area of this semicircle using x and y instead of numbers? Think about it and drop your answer in the comments. I'd love to see who can crack it. If this explanation helped you and you learned something new, don't forget to hit the like button, share it with your friends, and subscribe for more fun math puzzles. Thanks for watching, and I'll see you in the next video.